Hello, everybody. Welcome back to the last of these episodes, these lectures uh, concerning the math map and what's contained inside the math map. As you know, a few weeks ago, I went and gave just a small introduction to why we are using the math map, and then I went and even its purpose and so forth. And then the last couple of weeks, I kind of just took a look at the various domains that will be used throughout the students' years, from digits all the way to transcendental numbers. And then last week I looked at the dimensions that they will go through the 30 different weeks, which incorporate these various dimensions: 0D, 1D, 2D, 3D, 4D, and ND space. So last week again I just did 0 and 1 and 2D, but now I'm going to do 3D, 4D, and the ND, and take a look at the weeks that cover these dimensions. So without further ado, we'll go into the second part of the dimensions. So, and again, it's just a reminder of the various weeks that cover the various dimensions. And today's lecture is basically just going to look at these last three, covering weeks 19 through 30. So, as a reminder, I kind of kept to this from last week. So this is similar and actually the same as last week. This little part here talking about what the zero dimension as a dot, one point in space, and then we can spread that out and create 1D space, which is simply just a line. They're pretty much connected dots in one straight line across. And then if you pull that line vertically, you create a nice giant piece of paper of infinite length and width. Going up and down, you'll create the 2D space. Now, if we pull that space again in a third dimension, we'll get something that looks like this. This is more, it's all of space. It's what we think of in how we live, the dimensions that we use in everyday life. So these are the 3D. This is 3D space. Um, but in some sense, we technically live in 4D space. And again, we had you could see this in a couple of different ways. There's that the tesseract kind of space within a space kind of idea, or this other way where it's like taking space through time. And so there's this space and it propagates through time. So if you think about when we want to say, I want to meet somebody, I want to meet them at a, say, some coffee shop, and we set up a time, the coffee shop, and that place has some, we could find where they are based on some dimensions, some latitude and longitude, and we can plot where that intersecting spot is where we have to be. However, we need a fourth dimension. We can't just be at in the same latitude and longitude and distance from the Earth's surface. And if we're all there in the same, we can be there at the same spot in these three dimensions, but we actually need a fourth. Because if I come on a Tuesday and the other person comes on a Wednesday, we will still not meet. So the time factor requires is also part of our human experience. So, in a sense, we do live in kind of a 4D world when we look at this. So, it's not only the space where we're at, but at what time. So, not only where, but what time. So, we have to throw in that fourth dimension. And then we can kind of generalize it and go into a more greater dimension, which we kind of use our imagination. It's hard to really plot it out and look at it, but we can look at the patterns that when we use, when we look at the arithmetic and all the various things that we use in, say, 2D, and we can apply that to 3D, and we can apply it again to 4D, 5D, and so forth in the exact same way. So we can calculate these different dimensions, but um, it's hard to put it onto a piece of paper or onto a computer screen in a PowerPoint presentation. So it's more we have to kind of use our imagination. We have to kind of see the unseen in a sense when it comes to these spaces that are beyond 3D, 4D, and so forth. Okay, so again, we shared this last week. These are, and as you see, the patterns that flow from one D to the next D to the next D, and so forth. So, without any that put that all aside, that we already looked at it anyways, it was familiar. We will now go into the third dimension, the human space, the place where we live. Here is the where we will be dealing with human space within these weeks of 19 through 22. In these weeks, we're going to study things that we look at in 3D, so like 3D shapes. They have open shapes and solid shapes. So open just means that it's not closed off. It's kind of maybe some kind of parabola, but a three-dimensional version. Looks like more of a cone that just goes off into the unknown. Uh, and solid are more like, like a sphere or a cube or some kind of shape that's kind of got it's closed and it's got volume. Um, so this is what I'm talking about here when it comes to open and solid. So, and then we're going to look at locations. I mean, if you want to find where we're at, just like that Starbucks or that McDonald's or whatever, those kind of places, we need points. We need a latitude. We need a longitude. We need a way to find those things, and we can look at. So we give some idea of locations because that's what we do. We when we look at a map or when we are going someplace, we need to know where we're at. And then populations it will help us to look at, well, I think it's going to bring in some kind of graphs and so forth, and the use of data as we look at human space. So that's pretty much what we're going to do in these 4 weeks. So a little dive into per week, like I was doing last week with this. So week 19, that we're going to start using the third dimension, which has a third variable. So not only like your length and your width, but you'll have another axis, which is 90 degree to those two, which is the height. So not only an X and a Y, but also a Z. So we're going to add a third variable. We're going to try to work on things with a third variable. So the 2D plane, that flat plane that we were working on in 2D, will now become a 3D space. So the square becomes a cube, circle becomes a sphere. Get the idea. And then we can kind of now look at those patterns. Like when we're solving in 1D, we would solve an equation with only one variable. Then when we do 2, we can learn how to solve two equations with two variables. And now we'll go 3 equations with 3 variables. So the idea doesn't change. It's just we're adding another step, another variable. So we can apply that to down the line, 4, 5, 6, and so forth. So we can also find a point in space, just like we did on the Cartesian coordinate system, which is X and Y. We can find that point. Now we can find one in this 3D space. Polar coordinates, they'll call them spherical coordinates. So when you kind of learn the way to do polar coordinates with a radius and an angle off the origin, the x axis, the positive x axis. Now you're going to add another angle that will help you to find that point in space. Instead of polar, it'll be spherical. So now in week 20, we'll look at some solid shapes. We'll look at their terminology of solid shapes, like the face, the edge, which is different. So in two dimensions, you'll look at a square. You'll look at a square and you'll see the sides. Maybe you'll look at the vertexes, maybe the angles of the diagonal. But in a cube, Now you have a face. You have six faces. You have those lines that go around. Those are the edges. In a sphere, you'll have an equator that it's like and something called a geodesic. Geodesic. So that these are these kind of these curved lines. So on a sphere, it's very interesting that only the great circles that go around the sphere are the only ones that actually go straight. Any other curved, any other line, like if you look at an Earth and you have the equator, and then you have all those lines that go up, the lines of latitude, they go around as well. They're not straight. They are actually a curved line, even though they look like they're straight, but they're actually curved because the outside is a greater distance than the inside, so that it actually curves, even though it connects on each side. It's actually these geodesics of a curved surface. It's straight line is actually curved on a curved surface. Um, then you also learn about some measurements of like lateral areas. You'll learn about surface area and volume, um, given a few things there, different measurements of these solid shapes. Okay. And then let's look at week 21, which we talked about locations. We look at where and how far things are at, where they're located. And they talk about locus, which is like points that are at the same place based on a certain condition. So you could say what points um, are, you know, 2 inches away from a point. Well, all those they basically are a circle of radius 2 inches. So those are the locus, because based on that condition of being 2 inches away, um, that's the locus for that specific condition, for that point. So you look at various locus. Maybe the plural is loci. I'm not exactly sure about that one, but um, then there's, you look at distance, you look at conic sections. Conic sections is, um, there's actually, I didn't put a nice graph or kind of diagram here, but it looks like two cones touching at their point, and they go out. And if you slice those cones in a certain way, you'll get various kinds of um, various like open shapes like a parabola or a hyperbola or an ellipse or a circle. It depends on how you slice those two cones touching each other at a point. Um, so that's the conic sections. You learn these different shapes. Actually, you learned them earlier in as we studied like circles and ellipses and some of those things in the earlier dimensions. So that kind of these kind of sections will be shown here in this in the 3D space. Time conversions is there too. Um, just looking at, minutes to hours and hours to days and so forth, how to convert between the various times. So that's also in this week. And then finally, we get to week 22, which is the last of the 3D space. Um, so you look at this is populations. You'll get to look at visual forms of population and how you take that data and you can put it into various graphs and charts and tables. So you'll get to work with that, and you'll also get some probability here too. And look at the probability of various events happening. So uh, we'll get to look at that, a little bit of statistics type of stuff, and a fundamental counting theorem, and combinations and permutations. And you'll learn about factorials and there are those uses in using factorials, which is that little exclamation point, like 5 factorial, 5 exclamation point. You'll learn about that in this week. And There you go. I wrote it before I even showed it. I said it. Okay. And now we'll move on to the fourth dimension. So now we're getting another variable, another um, another part of the pattern as we move forward in our dimensions. And you get into some more difficult ideas. So now we're looking at intersecting spaces in the fourth dimension. So that's weeks 23 to 26. And in this, you'll look at two intersecting spaces or a space moved in time. That's kind of what 4D is. That's the idea of 4D. And you'll learn about matrices, so like linear algebra stuff, rates and rates of change, which gets into your calculus, along with accumulated change. So rate of change is like your derivatives. Your cumulative change is your integral calculus. So you'll learn that stuff in these weeks here. So starting with 23. As I said, some kind of linear algebra kind of stuff here, looking at matrices, how data is organized in an array form, and using matrices in order to solve systems of equations. Um, and they and also perform linear transformations using matrices. You'll learn how to perform operations on matrices, and you'll learn what the determinant is of a matrix. So these are ideas that you'll learn about matrices and give them some just like a good glance and a little bit of introduction into matrices. And then week 24, so rates, basically you're going to get into your distance, your speed, your velocity, time, and how they interact with each other. You're going to get to look at probably some like some graphs. Does the rate go up? Does it increase? Does it decrease? Does it do it increasingly or decreasingly? You'll get to look at that kind of stuff there in these rates. Look at task rate, slopes of rates. Remember slope back in the looking at just lines like linear equations. You learn about the slope, so he'll bring it. It comes back here in the rates because actually slope is very important when it comes to learning about derivatives because derivatives are basically slopes. So it's just slope at a point rather than slope over a certain distance or between 2 points. We're going to look at slope at a specific point. And so that's what the we get into here in week 25, the rate of change, which is kind of your derivative calculus. So derivatives, how derivatives relate to rates, and how derivatives rates to relate to slopes. So that's what you'll learn in that week. So learning how to handle derivatives. Also, then finally, you get into the other calculus, the integral calculus here in week 26. So this is accumulated change. So you're going to look at Riemann sums, kind of the basis for integral calculus, and learning how to add these these rectangles under a curved kind of surface, some kind of curved function. And when you add the rectangles, you'll approximate how much area is under that curved surface. And if the more the tighter you squeeze the rectangle to make them the width really, really small, you'll get really closer and closer and closer approximation to the area under the curve until you finally can get to the actual discrete number that represents the area under the curve. So you kind of get into learning that kind of stuff here. So, and you'll learn how to do integrals and how to calculate the integral. So that's what 4D has in store for them. And then we finally get into our final dimension, or dimension is very general here, which is the nth dimension. And there's not a lot. There's only a couple weeks for the nth dimension. So this is the n space. So we can continue our dimensions um, probably infinitely, just keep adding variables. And even though it's hard to, again, we can't really put it on a piece of paper or on some kind of computer. It's hard to see, but we can use our imagination and use the patterns of the lower amounts of dimensions to understand these higher ones. So weeks 27 through 30, and week 27 and 28. Um, oops. So we're going to just gonna say it. So must have taken out what I was supposed to say in here, but that's okay. Complex numbers is week 27. So week 27 deals with the complex numbers. So um, when you get into challenge A, you'll be in the complex domain. So this week gives you a lot more depth into looking at complex numbers as a whole. And so in this week, you'll learn about I, what it is, the rotation of I. You learn how to use complex operations like how to add to complex numbers, how to subtract them, how to multiply, divide, and various all the kind of the things around how to perform operations with complex numbers. You'll figure out find the distance of a complex number, its magnitude, and you learn some of these kind of operations around complex numbers. In week 28, we're going to look at proofs. So this basically you'll look at like different kinds of laws and axioms and theorems and way to use these in order to prove, say, the congruency of angles, or the why this triangle is the same as this triangle. So they'll go through a system of proofs and figure out, okay, this step, and okay, well, based on this theorem, this proves this. And then you keep doing that. It might be 5, 6, 7, whatever, how many steps in order to prove a given condition that they're looking for. So that's pretty much what the week 28 space is. And then finally, week 29, that is really the the seeing the unseen. And so this week is basically blank. And really, what this week is all about is what you seeing and going out in nature, looking at patterns, looking at symmetry, looking at math in the world, and writing those down in this workbook to share with the rest of your class, or just to have a nice just to see where math is in the world. And so this one actually is something you'll be doing throughout the semester, the year. You can start at week 1 and find something and put it in there. So this one is not really specifically just for this week alone. You could be doing it all along through your study that year. So it's a culmination of all the things that you saw in nature, in the world, that are about math. And week 1 workbook will give you a bunch of various ideas of what they could do. It'll show you that. So that's week 29. And then finally, week 30 is simply a week of reflection and maybe a preparation for the blue book for the challenge students. And just thinking about the things that they learned throughout the year, just like another assessment. You can use it, such as maybe write something that you learned that year. Whatever it is that you want to do in that space, you can do it. So that's really week 30. And so, okay, now we will get to the nth dimension. This is the final dimension, and it's the last few weeks of the year, which we'll look at these is very general, and it shows the higher dimensions, and we just continually use the patterns that we learned throughout the other dimensions to be able to apply it to, say, fifth, sixth, seventh, and so on, these dimensions. So in these dimensions, there's just a couple of weeks that we really have some material. So we'll start and we'll continue here. This is basically end space, and these will cover weeks 27 to 30. Complex numbers, proofs, seeing the unseen, and finally reflection. So in week 27, we'll get a little more in-depth focus on complex numbers. Um, Really only so those who are in challenge A, they'll be looking at complex number domain, and so they're the ones who will be more focused on using complex numbers. But actually you'll see it throughout all the domains. It just here in starting at challenge A, they will really focus on it and look at it. They'll do more work through these complex numbers. So you're going to learn complex arithmetic, like adding and subtracting and multiplying complex numbers. You're going to learn about complex rotation, with when you have I squared, I cubed, all that, how it rotates around to take a number and basically rotate it through the complex plane. So you learn about complex rotation, and you can look at rectangular, polar, and exponential forms of complex numbers. Then you get into week 28, and this is about proofs. In proofs, they'll use various forms like proof and axioms and theorems and etc. So they'll learn that, and they'll use two-column proofs in order to prove various math laws and so forth, that congruency of various sides and angles and shapes. So that'll be a time of just learning how to use proofs. And then in week 29, this week 29 is kind of one of these special ones. Really, you don't have to be doing it through only at this time here at week 29. This is called Seeing the Unseen. It's basically just a blank workbook that you can put in things that you see in everyday life. So it's really something that they'll be doing throughout the year. So when they're outside, they're looking at symmetry or patterns, or they're looking at math problems, or they see like shapes. They can put that down. And actually, um, uh, week first week, that workbook, that first workbook will give examples of various things that you can do for this week 29. And again, just they can be doing it throughout the year. They don't have to wait till this week to actually do this week 29. So the idea is just to get kids looking and seeing math all around them. um, Week 30 is reflection time. It really is kind of like the assessment in week 15. The assessment is they call it a reflection, to reflect on the year and what they learned through the year. Maybe they learned one interesting thing and they can write that in that. It's another way, like pretty much blank pages, and they could just use to assess the year. Maybe even use to assess maybe that final semester, just like the blue book. Um, so it's a especially the challenge kids will go into blue book and actually do some work based on what the director says. But it's just a nice way to look back and see what they learned and reflect on what they learned.